All right, so let's put this plan into action, shall we? Because it all seems kind of, weird until we can actually see a problem. So, in a survey conducted by the National Center for Health Statistics, the sample mean height of women in the U.S. aged 20 to 29 was 64 inches, with a sample standard deviation of 2.75 inches. Assuming that the heights of women are normally distributed, great, because that means we can apply the empirical rule. Wonderful. So it says construct an accurate normal distribution. Now, for the sake of sanity, I did draw this one with a computer program so you can see it has the horizontal asymptote action going on there. Lovely. So we need to put down the center. Rulers really help with problems like this, I have to tell you. So I'm going to have my center line go right down the middle. That's the mean. It's an X bar in this case because it says it's a sample mean. And they tell us the sample mean was 64 inches right here. It's telling us X bar. Doesn't hurt to label it right there in the problem, all right? So X bar is 64. So that goes down the middle. All right, so there's my symmetric center. And now comes the really tough part. I've got to get my inflection points and I have to get them correct. Okay, so what you need is a little bit above halfway. So from the top to the bottom is about 4 centimeters, a little bit more than 4 centimeters from you, like 4 1/4, right? So I need to be, 2 would be half, I need to be a little bit above half, right? And that's where I'm going to put my inflection points. So it's going to be, so let's see, if this is halfway, a little bit above halfway, I'm going to go right about there. Now, you're eyeballing it, but you're eyeballing it with intelligence, right? You're eyeballing it with a plan, which is that you want to go a little bit above halfway and have them be at the same height on either side. Then you can drop the vertical line. Oh, sorry, I'm nudging that paper too much. Then you can drop the vertical line straight down from that value. And from that value. And those two lines should look pretty identical, and that distance right there should be the same for both of them. Now, what is that distance? It's 64 for the center, and then I want to add on sigma, or excuse me, S, because this is a sample. The sample standard deviation is 2.75, so it's telling us S is 2.75. So I'm going to take my 64, I'm going to grab a calculator, 64 plus 2.75. Oop, I hit plus, but it didn't like me. There we go, 2.75. There's the next number. So this line over here is falling at 66.75. And then, well, I can do 64 minus 2.75. That gets me 61.25. Now keep in mind the unit for all of these is inches, right? Because these are inches. It's not super important right now, but we just want to keep it in mind for later. All right, now we have to keep going, right? We have to keep going to get the whole full empirical rule curve. So this distance right here, which maybe it'll be better with metric, it is about 2 centimeters. Matter of fact, almost exactly 2 centimeters. So this next line has to fall again at 2 centimeters. And so does the next one after that, 2 centimeters. And then over here, same thing. So I'm using my ruler to kind of measure this out. 2 centimeters, 2 centimeters. Of course, it just worked out to 2 centimeters. What I'm doing is I'm measuring this distance right here from the center line to the inflection point. Sorry about my dog. And because that's 2 centimeters, then every single one of these lines has to be 2 centimeters. And then I'll just go in and draw the little vertical line. I don't need to on that part. It's so tiny. And there we have it. We have all the lines drawn. Beautiful. The spacing is nice and even. The lines are straight and vertical. I can put in the percentages because the percentages never change. It's always 34 and 34, 13 and a half, and 13 and a half. Put the percent sign in there. Don't just put the numbers, right? Put the little percent sign because the whole thing has to make 100%. So this is 2.35%. And this actually goes on forever. You can put a little arrow on it. It's 0.15%, right? It keeps going. And then this is 2.35%. And this is 0.15%. And again, goes on forever. So the last thing I have to do is figure out the rest of my numbers. So it's 66.75. 66.75. Let me move this over. Plus 2.75. And then I'm going to add on another 2.75 to get the next one. So that'll get me, this number here is 69.5, and this number here is 72.25. So if you want to make notes for yourself, what you're doing is you're adding 2.75. You're adding 2.75. You're adding your S all the way along, right? And then you want to go the other way, you will subtract. So 61.25 minus 2.75, and then minus another 2.75. So that would get you 58.5 right here and 55.75 right here. And now we're finally done with part A. Whew. Okay, so to recap, we put the center line in, we labeled it with the mean. Then we found the inflection points, which are just a little bit above halfway. Those inflection points should be the same distance from that center line because it should be nice and symmetric. Then we took that same distance and found the next line and the next line and the next line and the next line. We're able to fill in all the percentages from the rule because the percentages never change. And then we were having to find all of the x values down here on the x-axis because those are found by adding on the standard deviation and then subtracting away the standard deviation, right? So you subtract 2.75, subtract 2.75, and so on. You technically could do it 3 times. Right? Once you have this done, part A, the rest of it's actually really easy. So it's just getting the graph done that's a little bit tedious. But once the graph is done, then all the answers will follow perfectly from it. So looking at the first one, they want to know what percentage of women have heights between 64 and 69.5 inches. So that's from this line right here to this line over here. So the percentage is 34% plus 13.5%, which is 47.5%. That's it. All right, what percentage of women are taller than 69.5? That's over here. Here's 69.5, so taller than 69.5 is these two percentages. So it's 2.35% plus 0.15%, which is 2.5%. All right, now what about the percentage of women that are taller than 64? Well, 64 was the mean. So by definition, half, right? Half of the women should be above and half of the women should be below. So 50 should be below, 50%, right? Which would be the same as if I added up those 4 percentages, I would get 50%. And I know what you're thinking. Well, what about women that are exactly 64? But your height is continuous. No one's exactly 64. They're 64.02 inches and 64.192 inches, and they're 64 point, right? There's always more decimal places if we can get it, right? So it's 50%. Now, what percentage of women are between 61.25 and 72.25? Okay, so 61.25 is right here. So I want to be between that number and 72.25. So I want to add up all the percentages in between. So it's going to be 34 plus another 34 plus 13.5 plus 2.35. And you stop right there. You do not continue on and you do not round. You're going to leave it at 83.85. So you want to leave the values from the empirical rule. Because if you round up to 84, you're actually including this percentage over here, which we did not want. We wanted to stop. So if we're going to stop, then it's 83.85%. Now, what heights of women would be considered unusual? So remember that unusual, make a note, means past 2 standard deviations or below 5%. All right, so this is just a note, right? We saw that earlier. Okay, well, past 2 standard deviations would be 69.5 and higher. Notice those percentages are less than 5%. See? And then short would be 58.5 and lower. So they didn't specify which way they wanted us to be unusual. So you could have unusually tall women, which would be 69.5 inches and above. So if a woman is 69.5 inches or taller, then they are unusually tall. Unusually short women would be 58.5 inches right here and less. So it would be 58.5 inches, so 58.5 inches and below. Oop. There we go. And below. Why? The explanation would be because they are past 2 standard deviations from the mean. Or you can say less than 5% of women fall into these regions. So you can see, once you have that empirical rule all drawn and written and labeled, then these questions actually weren't too difficult because they're using the percentages and the labels that are already part of the problem, right? They're already part of this graph, which is wonderful. So it makes it easier for you. But you have to do a very good job with this. So I can't stress that enough. Make sure you keep your spacing even. Make sure your inflection points are where your first standard deviation falls. Make sure all your lines are vertical and your spacing is even and consistent. You want consistent spacing. Every single group should be the exact same width. The percentages always stay the same. The x value numbers on the x-axis change for every problem, but the percentages are always what they are. And then keep your spacing nice, vertical, even, and make sure that that first inflection point is where the first standard deviation falls. Sorry, the inflection point is where the first standard deviation falls. And then everything else will fall from it.